I've got a pile of 2x6 offcuts and I wanted a way to join them on the end grain to make them longer to make a new workbench out of. The simplest joint, at least conceptually, would be to just do a butt joint like this. The trouble is, this is not very strong. I also want to do it entirely with glue and nothing like dominoes or dowels. Another option which would work would be to do a half lap joint like this. This gives a nice long grain glue surface, so it makes for a fairly strong joint. However, it does significantly weaken the portion of wood because it comes down to about half as thick as it normally would be on the vertical axis. There's also a fairly common joint called a scarf joint. By cutting the end grain on a long angle like this, it makes a much larger glue surface for a stronger joint, and it can work just fine. However, I'm not a real big fan of this because actually clamping a glued joint together is kind of a pain in the butt because the pieces want to slide against each other no matter which way you glue them. You end up having to have counteracting forces on both the top and sides. Of course, there was an obvious answer staring at me in the actual surface of my workbench with a little finger joint like this. However, recently on a much better YouTube channel than this one, Matthias Wandel tested those joints and found them to be pretty lacking. Individually, those finger joints are not all that strong, and it doesn't really matter on something like that workbench top because they're laminated together, but I can't guarantee that all the pieces I'm going to be splicing will be laminated together, so I wanted to try something a little bit more like what Matthias did. Matthias made a V-shaped joint on the table saw that would get tighter as more pressure was applied to it, and I wanted to do something similar. My 2x6s are a lot wider than what Matthias was joining, so I wanted to make joints with multiple fingers. With the tools I have on hand, making templates to use on a router table was probably going to be my best bet, so I started by making the best templates I could out of some 1/4-inch plywood. I wanted to show that these templates could be made without any sort of CNC machine, so I really tried to take my time. When Matthias was strength testing the finger joints similar to the ones in my workbench top, he found that they really weren't all that strong individually, and the reason is that the fingers don't extend very far into each piece of wood. Similar to his design, I made my fingers between 2 and 3 inches long. I cut these as precisely as possible on the bandsaw and then did a little bit of cleanup with a file. After I finished that first half of the template, I used it to trace out the corresponding side. Once again, these pieces got cut out, and then I spent even more time with the file, really fine-tuning and trying to get these two pieces to fit together as tightly as possible. So to make sure that this joint could slide against itself and close as tightly as possible, I removed the tips of the triangles. If I didn't do this, they would bottom out as the joint closed and prevent the longer sides from fully contacting each other with the glue. And another reason why I had to cut those tips off is that after I do this on the router table, there's not going to be a nice little V point for them to go in anyway, it'll be round. I attached a straight edge to each side of the template with some glue and brad nails. I did this to try and keep the joint as square as possible to the actual length of wood that I'm joining. So for my first test, I just cut up some pieces of scrap pine that I had and traced out where the template would actually sit. I also realized at this point that I needed to trim my test pieces down to the exact same 5.5-inch width that a 2x6 is. Most of the excess was removed on the bandsaw. I used double-sided tape to attach the templates onto my test pieces. This gets a little tedious after a while, and when I start actually joining all these 2x6s together, I might do this with screws. I did all my initial tests just using a 1/4-inch flush cut bit. I was using such a small bit because I wanted to try and keep that rounded part at the gully of the V shape to be as small as possible. Once cut, I removed the templates and the joint fit together pretty well. I glued the joint together, and though I probably could have gotten away with just putting clamps on the ends like this, I added one to the middle to squeeze in the outer fingers. Overall, I was pretty happy with how this joint came out, but I thought maybe I could make an even better template. I whipped up a design and then sent it to the laser. This was by far the fastest and most accurate way I had to be able to cut out the template, though I did find that the laser caused a few problems in my later testing. I really had not spent very much time designing this template, so I still had to manually round off the tips. Everything else was pretty much done exactly as before, and when I removed the templates I found that it had an even better joint than my initial test. I'll add though that in my haste to design this template, I made the joint way bigger than it really needs to be. This lost a total of 12 inches off the entire length because each side of that goes to be about 6 inches long. I ran both the laser and hand cut samples through the drum sander. I did this so I could get a better view of exactly how tight the joint was, since pine tends to kind of burnish and brown over a little bit on the edges. The hand cut template wasn't perfect, but it was pretty good. The laser cut one was even better. This one had almost no gapping at all except right at the tips, and because I had made it in such a way that the joint could continue to slide in on itself, when I clamped it, everything closed up really tightly. When I flip the samples over, you can even see how much better the laser cut one was. On the hand cut sample, the backside showed just a little bit more gapping. The backside of the laser cut sample though still looked great. When I moved on to the 2x6s, I initially tried to make 3D printed templates. I figured these would be a little bit more durable, but it turned out that the plastic was just a little bit too flexible to really work, especially with that long skinny bit. Part of the issue was the design, and the other part was that I printed it in PETG, which is a little more flexible than PLA. I did try stiffening them by gluing on some wood strips, but it turned out that this didn't matter at all. I had sized these templates for a 1/4 inch flush cut bit, and my bit was not actually tall enough to be able to use on a 2x6. So I went back to laser cut templates, and because of the thickness that I needed, I sized these up to be able to be used with a 1/2 inch router bit. The 1/2 inch flush cut bit that I have has about 1.5 inches to almost 2 inches of actual cutting length, whereas that 1/4 inch one was barely an inch. I also added these little half moon windows into the template. These serve two purposes, one of which I'll get to a bit later in the video, but for right now you can see they're used to help line up the fence. I also tried putting a fence on both sides, which was nice because it held the template on there a little bit better, but because 2x6s aren't always to the most perfect standardized widths, it could sometimes get in the way. As a disclaimer, I'm going to add here that I don't think trying to end grain glue 2x6s together to make some kind of major structural component in a building would be very smart, but I think using this lumber in this method to make a new tool bench will be just fine. Initially, I thought I got a really nice tight fit, even without taking the tips off of the fingers. There didn't appear to be any gaps, and there was no play in the joint. I proceeded to glue the joint together. I didn't have any clamps long enough to really properly do this, so this is my first and very bad attempt at clamping this. This did not work, and when the glue dried, I was able to make the joint fail with a minimal amount of effort. So I tried this. It's a 2x4 with a stop block fixed to one end. I put some tape down in the spot where the over-squeezed glue would come out of the joint. On the other end is another fixed stop and two wedges that when squeezed together will expand to create the pressure I need to close the joint. Here you can see it in action. I still ended up adding a clamp to the center just to hold everything down and keep it all straight. After everything had dried, I threw this board through the planer so I could get a better idea of what the joint looked like. What I saw was not good. You can see in this video daylight coming through a lot of the areas of this joint. To understand why this came out so bad, I had to go back to my template. In my attempt to make this joint aesthetically pleasing, I lost the entire function of the joint being able to close in tightly upon itself because now it was bottoming out on its own fingers. Additionally, it appeared like the kerf of the cut was wider in some spots than others, and to understand why that is, you have to know something about diode lasers. This isn't the sort of thing that most people would ever give any sort of consideration to, but the beam of a diode laser isn't actually round like you might assume. It's more rectangular shaped. This is not a great representation, but you can see how when the laser moves along the cut path, it's wider and narrower in different spots depending on which direction it's going. I could sand the tips of the fingers off if I wanted to, but because of the way I shaped this, these two spots here will still bottom out no matter what. To jump back to my original laser cut sample, once again you can see I didn't do that on this particular template, and as a result this joint was able to close very tightly. So here is version 4.0. I removed the tips from all the fingers and now the joint can close in tightly on itself. This closed up so tightly, in fact, that this is being held up just from one corner and nothing else but friction keeping it together. And look at this, no light coming through on any of the long glue surfaces. With repeated use, double-sided tape will damage plywood templates, so I wanted to transfer these onto acrylic because I have a lot of these joints to do and I don't want to have to remake the templates repeatedly. I basically just made these templates the exact same way that I've cut all the other joints, and the reason I did not cut the acrylic out on my laser is because you can't cut clear acrylic on a diode. You have to have a CO2 laser, and I do not have one. I really should have taken more time with the bandsaw and removed more of the waste because this was kind of pushing the flush cut bit to the max. And like I mentioned earlier, I think I'm going to add some screw holes to be able to hold the template down that way rather than using double-sided tape for all the joints that I'm going to have to do when I actually get around to making the workbench. This is the joint just held together with friction, and I can tell you when I tried this the first time with the other template, the joint would not have stayed together like that. After the glue had dried, I ran this board through the planer and the joint looked way better than the first one did. It wasn't perfect, but it was well within how good I wanted it to be. Here's a side-by-side comparison of the two, and the difference in the gaps is night and day. A lot of these pieces are going to get laminated together overlapping kind of like this, and that'll make even stronger beams that I'll use to make my new workbench. The whole time I was playing around with these templates in this kind of joint, I had this idea in my mind of trying to make it where I could have overlapping teeth within one single piece of wood. In theory, this would more than double the amount of glue surface available to the joint. To make it work with these templates though, I would have to make sure that they were very precisely aligned, and that's where this little window really comes into play with this marking line. Each side of the joint will use both templates, one on each side, and I need to make sure that they are lined up perfectly to each other. Now because each side of the joint won't go all the way through the entire thickness of the wood, I had to use a different kind of router bit to do this. Most top-bearing router bits only size to 1/4 inch shanks, so I'm going to do this all with the trim router, which is a lot easier to control anyway. The stock I'm cutting is 3/4 of an inch thick, so I cut each side of the joint in 2 passes, one about halfway through and then a finishing pass so I didn't overburden the bit or the router. After cutting the face on each side of the joint, I flipped everything over and swapped the templates to the other sides. And this is why I made those other templates out of acrylic. The plywood is just a little too fragile for repeated use like this. I did a quick repair on the template and proceeded on with cutting my joint. Chronologically, I made this joint while I was waiting for the glue to dry on my first failed attempt with the 2x6, which is why I'm still using the template that doesn't have the fingers removed. As I am doing this joint with hardwood, I think it would be more appropriate to try and get it to look more aesthetically pleasing, and because of the overlapping feature, this joint is still plenty strong even with a little bit of gapping. Cutting this took about a half hour, and when I was done, they fit together almost perfectly. It took a lot to get the joint to squeeze together, but make no mistake, this was just friction from all the different surfaces. There wasn't any bending or cracking or anything like that. Once the joint was together, I couldn't even pull it apart by hand. I had to put one end in the vise and start wiggling. I'm not sure what, if anything, I would ever actually use this joint for, but I'm going to call this a success. Of course, there is still gapping, but maybe with further testing I could tighten this up. I'm not going to pretend like I got it that good on the first try, though. Here was my first attempt, and it was pretty much hot garbage. Well, with that, I'm going to wrap this video up. I hope it's useful to anyone that might find themselves needing to connect end grain pieces together to make longer boards, and if you made it this far, thanks for watching.